Okay, so today is properties of integrals. Kind of have to put all of these in your brain. So this first one is if your upper bound is smaller than your lower bound. If you switch the bounds, you negate the integral. So this is going to be from A to B. So if you switch the bounds, you have to switch the integral. Okay. This next one is there's no width. So if there's no width, you can't find an area of a rectangle. So the area of it is 0. Okay. For a constant, so say I'm going from 3 to 7 of 2 dx. This, if you think of what the graph looks like, this is a horizontal line at 2 between 3 and 7, right? So it's a horizontal line, right? It would keep technically going, whatever. But I would only want it from here to here. This is just straight up rectangle, right? So this is the C, whatever this number is, that's your 2. That's like your height. And then this guy is your width. Okay. Another property of integrals is that you can separate them with addition and subtraction. If you have a constant, like a 5 in front, you can keep that in, put that out in the front. The only big thing is you can't do it with multiplication or division. That's a later day. Okay, this last one down here is, say you have A to B, and then you're finding the area under this curve. Okay, so if this is some value C, excuse me, so here's your C, you can find, like you can break up integrals, like find the area from A to C, and then find the area from C to B, and that'll give you like the full area. So that'll give you like the whole thing if you were to go from A to B. All right, this guy, find the exact area bounded by the x-axis. Okay, so for width is always positive. So what you're going to do for this one is you're going to find the area of, because it's just a straight up triangle, of a triangle. So you're going to go 1/2, the base is 6, height is 3, so 1/2, 6 times 3, oops, not 63. And then because this other part of the graph is below the x-axis, you're going to subtract it. Because think about like your heights are negative, okay? So every time it's below the x-axis, it's going to be negative. So you're going to go, 1/2 base, what is that, a 10? Yeah, 4. And then this is like technically like a -2, right? But I just always remember to subtract when it's below the x-axis so I don't have to deal with negatives. So then when you solve that, you get what, 9 minus 4, so you get 5. Express the shaded region as a definite integral. So in the integral world, you don't need to account for like the negative area, like it's part of its notation. So all you have to do is go from 0 to 10, and then you find the equation of a line. So what is this, 3, and then what's the slope of this thing? Down 3/6. So down 3/6, so -1/2. So it'd be -1/2 x plus 3 dx. So you don't have to like actually deal with negative area, like that's already taken account of in the integral. Okay. So now what we're going to do is find the exact area of the integral. So what you're going to do is you're going to essentially draw a sketch of the graph. So, excuse me, here we're going from I mean, this graph here, let me open that in blue. This graph, the way you want to think about it is like f of x equals 1/2 x. Like this is a line. So what you're going to do is just graph the line. So technically it'd have the y-intercept of 0, but really we want it from 2 to 6. So kind of a cheat way to do this is I usually just like plug in like f of 2 and then f of 6 to get like my 2 order pairs. So I plug in 2, I get 1. And then if I plug in 6, I'll get 3. Right? So then here's my like line. Because I know it's going to be a line, so I kind of cheated a little bit. And then what I'm going to do is find the area under here. Okay, so you could do like a triangle or a rectangle, or it's faster just to do a trapezoid in my opinion. So this is a trapezoid, so I'm just going to go 1/2 the height, which is 4, times the sum of the bases, so that's going to be 1 and 3. So 8 is the answer. This next one, B, is kind of goofy because you're like, sine, what? Well, if you graph it, a graph of sine from 0 to 2 pi, I'm going to try to graph it, right? But this would be pi, this is 1, -1. Okay, well, this area is all like positive, right? Because it's above the x-axis. And then this area is all negative because it's below the x-axis. I tried to draw it right? So they would cancel each other out because it's symmetric. So this area is just going to be 0. Okay, next one is, here we have like a piecewise function. So, did I skip one? Nope. Okay. So this one is, you kind of break it up into 2 parts. So for this one, I'm going to, between, well, -3 and 0, I'm going to have to use this equation. And then for the other one, from, what would it have to be then? 0 to 2, I'm going to have to use this equation. So essentially, you could graph them both if you want. You could treat them separately. But like if you were to graph them both, right, we're dealing with -3 to 2. Well, for this up until 0, I'm going at a horizontal line until 4. So this is just like straight up rectangle, right? So I'm just going to go, what is this, 3 times 4? And then this guy is like a V, but moved over 1. So if I put 1, these are like 2 little triangles. Well, they're the same though. So you could just think of that as a square, 1 by 1. Or you could think of them as 2 triangles. Excuse me. So either way, you just add them all up and you get 13. Okay, this next one. Sorry. You have to use the idea that you can separate integrals. So what I'm going to do is I'm going to go -3 to 2 of f of x dx plus, and then -3 to 2 of 4 dx. So that's totally legal to separate them. So now when I plug in like the actual like integral here, I'm going to put that negative outside the integral and do x plus 2 dx. So I can put that negative out front. And then 4, is just like a straight up rectangle. So maybe I could do that right away. Maybe I'll just leave it. Okay. And as far as like this guy, I'm just going to look at them as completely separate integrals. So this is -3 to 2, and it's a horizontal at 4. So this is just like straight up rectangle, right? So that's going to be, oh shoot, I should have left more room. This is going to be what time? 5 times 4, right? To find the area of that. And then
alert, room 312.
for this
alert, room
blue,
312.
the pink one, if I drew a picture of it, okay, this would be another absolute value, but left. And because I kept the negative, I didn't do the reflection on it. So really, I'm just focused on this guy just because it's easier to graph. So this is just an absolute value graph over 2, right? So it's down over at -2. So if I'm just going from -3 to 2, figure out this ordered pair by plugging in -3. So if I plug in -3, this is going to be at 1, right? Oh boy, I didn't make this that big enough. But like, if I do 2 over here and I figure out what is f of 2, just plug 2 in and you get 4. So this goes up to 4. So it helps you like figure out what your bounds are. So you're doing like 2 triangles. So I have negative and then 1/2 base times height. Okay, and then you have to do the other triangle. So 1/2, and then this thing is 4 times 4. And then if you add that all up, I'm gonna move this over here, you get -1/2 plus 8 plus 20. So then this is 11.5 is what it ends up being. Okay, comparison properties of integrals. It's basically saying, like, if you wanted the absolute max value of an integral versus the absolute minimum of the integral, what you do is you figure out what the maximum, like, what's the biggest rectangle you can make. So this is like the largest height. Okay, and then this one is the smallest height. So imagine making a giant rectangle. So the smallest rectangle that I could make, or the smallest area, would be using the smallest height. So this b minus a, these are just the width. And then similarity, this is like this is the biggest rectangle you can make. So think of like one giant Riemann sum, and the smallest Riemann sum you could possibly have. So what you do first for the comparison property to estimate the value, the first thing you do is figure out your absolute max and min. So you let your f of x equal like whatever your equation is in the integral, because that's like what the graph is going to be of, and then you're going to find the area underneath it. That's what the integral's for. So like when you find a max, you like find the derivative. So what would that be? 1/2 x cubed plus 1 to the -1/2, and then times 3x squared, because I got to do chain rule. And then remember, you set equal to 0. So that would be this thing. Right, so then that is when set the numerator equals 0. So 0 is when that happens, which is actually really annoying because this is like not on the interval. So that was like kind of lame. So I didn't really have like a critical point. I don't have like I don't have, like, my graph's not going to go like this or this, you know? So I'm going to have to really it just seems like the graph is going to be increasing, it seems like. So I'm going to make a table just like I usually do, but I don't even have a critical point. So I'm going to check 1 and 2 because those are my intervals. And if I plug it into f of x, so f of x is that x cubed plus 1. If I plug 1 in, I get root 2. And then if I plug 2 in, I get 3. So like if you were to look at the graph of this, okay, you're going to get root 2 when you plug in 1, and then 3 when you plug in 2, right? So it seems like, I mean, I know what the graph looks like. This is going to be an increasing function the whole time. So what you're going to do now is your second step is you're going to find the area of the small rectangle and the big rectangle. Oops, I wanted that in blue. Whoops. So like if you were to make a giant rectangle, so the smallest rectangle you can make is using the smallest height, which is right here, because that's the smallest value. So the smallest rectangle I can make is this guy. So my width is 1, but my height is root 2. Then I'm going to go less than or equal to is going to be 1 to 2. So I'm rewriting the integral. And then my biggest rectangle I can make is using the biggest height I have. So the width is still 1, you know, but the biggest rectangle I can make has a height of 3. So when they say like describe the range of what the area could be, would be between the area of this, or the value of this integral is between root 2 and 3. Because we're going to learn how to integrate these, and that is extremely difficult integral to solve for. So there's a worksheet for homework, and